Welcome to You Can Do It Maths. Today we're doing the 2021 October-November paper 42. This is going to be awesome. Question 1a, part 1. Malena has 450 trees. The ratio is 8 to 7 to 3. So first of all, that ratio means if she has 8 apple trees, 7 pear trees, and 3 plum trees, that will give you a total of 18 trees. The thing is, though, she doesn't have 18 trees, she has 450 trees. So if we divide that by 18, we know what the unsimplified ratio is. So 450 divided by 18, 25. That is the unsimplified. So that means if we want to know how many apple trees she has. Apple is the first ratio. We need to do 8 times 25 equals 200. It's a show, so that means you need to show every step of your working. Part 2, find the number of plum trees. Now plum is the last number in the ratio, so we do 3 times 25, which is 75. Okay, part 3. She wants to increase the number of pear trees by 32%. How many pear trees do we have? Well, we don't know. The ratio is 7. So first we need to work out how many trees she has. So that's 7 times 25, which is 175. Now, whenever we increase something by 32%, we take 100%. That's the total amount we have. We add 32%. And we'll end up with 132% of the original value. As a multiplier or decimal, that's 1.32. So we do 175 times 1.32, and that gives us 231 pear trees. That is not our final answer, of course. Okay, it says the number of extra. Okay, so it means we need to subtract that 231 minus 175. 56 is the number of extra trees she wants to buy. Right. Part 4. A lot of information here, so you need to work step by step. Okay. First thing, we need to see how many apples does each tree produce. Okay. So, if each tree produces 48.5 kilograms of apples and each apple weighs 165 grams, we need to divide that to find the number of apples, but it's not the same units. Okay, remember to change from kilogram to gram. Kilo means 1,000, so we need to times it by 1,000. 48.5 times 1,000, so 48,500 grams divided by 165 grams, and there we get 293.93 recurring apples. So let's think carefully. Let's leave it like that. This is not our final answer. We are going to leave it like that. We don't need to round it yet. The total number of apples produced by 200 trees. So if each tree produces 293.93 recurring apples, we times that by 200, and then we'll have the total amount of apples. Okay, brilliant. And we write that down, 58,787.87, etc. Okay, now they want the answer correct to the nearest 1,000 apples. Where's the thousands there? We cut it off there. Next to the 8 is a 7, so we need to round it up to a 9. 59,000 apples. Question 1b. Malena has land is valued at 3,075,000. Write this number in figures. Be very careful. Yes, it looks easy, but it's easy to make a mistake. 3 million looks like that. 75,000 looks like that. So don't leave out that little 0. Question 1b, part 2. Write your answer in standard form. So, standard form is when we write a question as a number between 1 and 10 times 10 to the power of something. So we need to move the decimal point from the end of my number to just after the first digit, which is right over there. So we moved it 1, 2, 3, 4, 5, 6 spaces. So this is what it looks like. It will become 6.075 times 10 to the power of 6. No, what did I write? 6. 3, of course. Why did you change the 6 to a 3? The 6 is up there. Okay. You can do this automatically on your calculator. You can press Shift, Setup. Number format is number 3. I want to change it. I want to change it from normal to scientific notation. So you press 2. And let's do significant figures. Let's make it 4 significant figures. So now if I put the number 3,075,000 into my calculator, it will automatically change everything to standard form. Yeah, if you want to change it back, you press Shift, Setup, change the number format to press 3. I want it on normal, so I press 3, and then you press 1 or 2. That doesn't make sense. Then the answer is back where we were. One more comment on question B, part 2. Don't round this answer. It's an exact answer, so you leave it where it is. If you round it to 3.08, it is wrong. So 3.08, that would be wrong. Okay. Exact answers, leave them as they are. Question C. In 2020, each plum tree produced 37.7 kilograms of plums. This was 16% more. So now we're moving back in time. Okay. So, first of all, 16% more. Whenever you increase something by 16%, is always the same calculation. You take 100%, you increase it by 16%, you'll end up with 116%, or as a multiplier, that's 1.16. So if you take the trees in 2019, okay, that's the original amount. To increase it, you multiply it by 1.16, and then you'll get the amount in 2020, which was 37.7 kilograms. But we're now going back. So we need to work backwards. We need to do 37.7 divided by 1.16, and that will give us the original amount. So let's do that. And that's 32.5. Now that makes sense, because if we increase to 32.5, it will become 37.7. Question 1D. Malena invests $1,800 at a rate of 2.1% per year compound interest. Calculate the value of her investment at the end of 15 years. So remember, we're doing the compound interest formula, which is A, the amount, total amount, equals P times 1 plus the rate over 100 to the power of n. P being the principal, the original amount, and n being the time. So it will look like this. A equals the original amount, $1,800. The rate is 2.1%, so it's 1 plus 2.1 over 100. And the time is 15 years. Let's see what that looks like on the calculator. 1,800, 1 plus fraction 2.1 over 100 to the power of 15. Okay, which gives us an answer of 2,458.5. 4, 3, etc. Now this is not an exact answer, so we can round it to 3 significant figures, which is 2, 4, there's an 8, so we round that to a 6, 0. Question 2a. First, they want us to find the median. Remember, the median is half the middle value. So having 80 houses, the middle would be, of course, 40. So that's where we find the median. Use a ruler and a sharp pencil and show this. We go across till we meet the graph, and then we go down and we look carefully. We're exactly halfway between 80 and 100. So that is a median of 90. Now the lower quartile is the bottom half of the bottom half, or 80 divided by 4, which is 20, or half of 40 is 20. Either way, the lower quartile will be over here. So again, ruler and pencil, draw a line till you meet the graph, go down straight and look carefully at the values. Okay, be careful now, this is not 64 because 70 is right there next to it. So each small square counts for 2 values. So if we got 4 squares, 62, 64, 66, 68. Looking at the intervals is very important. The interquartile range means now we need to have the upper quartile as well. So let's do that. So upper quartile is the half of the top half, or 3/4. 3/4 of 80 is 60, or 75% of 80 is 60. Okay, either way, the upper quartile will be there at 60. So again, working accurately. Go across. Go down, and bam, straight on. 120. Now that's the upper quartile, of course. 120. The lower quartile was 68. So the interquartile range, we subtract the one from the other, and we get 52. Last question here. The number of houses with a floor area greater than 120 meters square. Now, where do we find 120 meters square? There's the meter square. There's 120. Well, we already used our graph. Okay, so we get to 60 houses. They want to know greater, so we're talking about these houses. They're all greater, which is 20 houses, of course, from 60 to 80. The answer there being 20. Right, question 2b. We need to work out an estimate of the mean. Remember, mean is where we have to add everything together and divide it by how many there is. And what is everything we have to add together here? The floor area. The floor area. We get it all together and then divide it by how many floor areas there are. Here we go. Now, there is 14 houses with a floor area between 40 and 60 meters square. Now, we don't know exactly what is the floor area of those houses. That's why we're going to have an estimate. Okay, so we're going to have to take the average, and we assume the average is the midpoint of 40 and 60, which is 50. So on average, they'll have a floor space of 50. So we need to get all those houses, all 14 of them, we need to add up all their 50 meter square floor spaces. And that's what we do with the rest as well. We take the frequency, in this case 17, and we multiply it by the middle, which is 70. 18 times 90, 15 times 115, 9 times 145, 7 times 180. That will give us the floor areas of all the houses, all added together. Then we need to divide it by how many houses in this case there are. We can do that by adding up the frequency, or if we just read the question carefully, they already told us there's 80 floor area, so we need to divide that by 80. So let's put that into the calculator. Putting it all at once is always best. So what I get is 97.5. Always think, does this make sense? Where is 97.5? It will be over here, somewhere between 80 and 100, which is roundabout in the middle. So it is a valid answer. It makes sense. If it was less than 40 or more than 200 or too big, falling somewhere else on the table, which is not the middle, we know it doesn't make sense, and we know we need to try again. It's easy to press the wrong button and get the wrong answer, so double check that your answer is right. Each step of the working out is also very important. You get a mark for showing the midpoint, you get a mark for multiplying, adding together, you get a mark for dividing by 80, and then you get a mark for your final correct answer. Question B, part 2, with histograms, remember the formula. All right, easy way to remember it is that the area of a bar is always equal to the frequency, meaning if you take the width of the bar, which we call the class width, which I abbreviate to CW, and you multiply it by the vertical axis, which is the frequency density, you get the class width. So frequency density times class width equals frequency, and you can change that into one of those little triangles that work so well. Okay, so frequency FR equals frequency density times class width. So what we need to do now is find the third bar in this histogram. So we go to the third box here. The class width now is 20 from 100 minus 80, and the frequency is 18. So it will be 18 divided by 20. Where shall we do that? Let's do it over here. 18. They don't give us much space, do they? 18 divided by 20 will of course give that 0.9. Look at the scale on the vertical axis very carefully. Each two squares counts for one value, so 0.9, or it goes up by 0.05 for that matter. So 0.9 is what we're looking at here. So we're going from 80 to 100. Now if you're one square off, you lose a mark. In the examiner's report, they specifically mention students losing a mark because they went to 0.95 instead of 0.9. So make sure you got the two square space. As well, it was mentioned to use a ruler and a pencil. Students lost marks because they did not use a ruler and their work was not accurate enough. Going on there to the fourth bar. Now the class width is 30. The frequency is 15. So 30 divided by 15. No, of course that's not going to work because you got it the wrong way around. 15 divided by 30 is 0.5. So from 130, go up to 0.5. Next bar, class width again is 30. So 9 divided by 30 equals 0.3. Check the scale carefully. 0.3 is 6 squares up. and the last bar, class width is 40. 7 divided by 40 equals 0.175. 0.175 would be halfway between the third and the fourth square. Accuracy is very important. Question 2b, part 3, probability. We're picking two houses. One floor area greater than 130, the other has a floor area less than 60. So let's first check that, right? Floor area greater than 130 will be these 9 houses and these 7 houses. So there are 16 houses with a floor area greater than 130. We have to pick one of these houses out of the total amount of houses, which of course was 80. Then picking a house with less than 60 will be these 14 houses. Okay, so that's 14 houses less than, but remember now we already picked one house. We're not going to pick the same house twice, so it means there are 79 houses left. So for this to be true, for this to happen, we have to pick the one and the other. All right, so that means we're going to multiply. We're using the multiply rule for probability. So let's do that. Right, so that gives a probability of 14 out of 395. But there is another possibility that can happen here. We can do the same thing but in the reverse order. We can pick first the house with 60 meters or less. First one of those 14. Okay, and there will be 80 houses still when we pick that pick. And then pick the house with a greater floor area and when there's only 79 houses left. Now this will give us the same answer, of course, because it's 14 times 16. Okay, so in the end, it gives us the same probabilities, just in the other order. So there's two possible events that can happen, the one or the other. When we have the OR rule, we need to add it. So meaning we need to add these two probabilities together. Or if you want to speed things up, you just multiply it by 2. Okay, and that will give us the final correct answer of 28 over 395. Question 3a, triangles, trigonometry. Immediately we need to start thinking, if we have a right angle triangle, we are going to use either Pythagoras or SOHCAHTOA. Any other triangles that's not a right angle triangle, it's either the sine or the cosine rule. Right, so the first question there, calculate AD. Let's mark it. AD is this line here. And show that it rounds to 94.5. So that's actually given us the answer. So AD, let's see, AD is in this triangle. Triangle ADE. See that? And what do we have? Right angle there. Okay, if we want to use the Pythagoras, it means we work with side lengths. Okay, we have one side there, 46.1, but we don't have the other side. If we include angles, then we use SOHCAHTOA. So that's what we're going to do. We got angles and sides in a right angle triangle. That is SOHCAHTOA. So let's get started. Let's first label our triangle correctly. This is the 90-degree angle. Opposite that is the hypotenuse, which we are not using. We have right next to the angle 46.1. That's the adjacent. And we want to know AD, which is the opposite. So we're using O and A, which means we're using the tan ratio. So let's write that down. Tan, then the angle 64 equals the opposite, which we don't have. So we're going to label it AD over the adjacent, which is 46.1. Let's rearrange that to work it out. So we do 46.1 move it to the other side, that becomes multiplying. So AD would be 46.1 times ton 64. And there we go. 94.5190, etc. It's important to write the unrounded answer because they said show that it rounds to 94.5. So you write the unrounded answer and then you write the rounded answer, and that's how you get full marks. Question B, part 2. Calculate angle BAC. Let's go and mark it. There it is. BAC. So it's this angle over here that we want to know. Right, it's not a right angle, so we can't use Pythagoras, we can't use SOHCAHTOA. It's a triangle where we're going to have to use the sine or the cosine rule. Now, for the sine rule, always look for opposite angles and sides. If you got an angle and the opposite side, you know you're going to use the sine rule. In this case, we got this 94, and right opposite it, we got 78.4. That means sine rule we are going to use. So, to make things easier, you start off by what you do not know. Let's make that angle we don't know. Let's make it x. So we start with the x. Okay, write it down. I want to know what x is. Sine rule is always sine and then the angle, so we're going to put the sine at the top. There's another version of the sine rule where the angle's at the bottom, but always put what you want to know, top left hand corner. Opposite side here is 56.5, so that put that over 56.5 equals sine the other angle we have 94, 68.4. Now to calculate, we need to rearrange. First, I'm going to multiply this 56.5 on the other side. And then I want to move the sin. So it will be the inverse of sin. And then the rest. So let's put it into a calculator like that. Shift sin, fraction 56.5 times sin 94 over 78.4, close bracket, equal error. Let's try again. Shift sin, fraction 56.5 times sin 94, close that bracket, over 78.4, side arrow, equal, and we get 45.964, etc. Rounded to 3 significant figures. I mean, we're going to cut it off there. There is a 6 next to the 9, so we need to round up the 9 to the next value, which will give us 46.0. Question 3a, part 3. Calculate the largest angle in triangle CAD. So let's have a look here. Triangle CAD. There it is. And what do we have in that triangle? We got 3 sides. Okay, now same as before. Sine rule is when we got opposite side and angle. When we got 3 sides, we're going to use the cosine rule. All right, now there's different versions of the cosine rule. And when we want to work out an angle, it's better to use the rearranged version, which is this one. Okay, you can use this one and then rearrange it. but it will be quicker if you could memorize that. So let's see what that means. Let's write down the formula first. Formula is cos A equals B squared plus C squared minus A squared over 2BC. What I'm going to do next is I'm going to relabel my triangle. First of all, I'm going to make capital A the angle I want to know. Now, looking at this, I know it's not to scale, but it still seems pretty clear that the biggest angle is this one up here. Okay, so that's the one I'm going to know. Let's label it X to make things go quicker. And I'm going to make that A, which means the opposite side here is lowercase a. The other two angles, it doesn't matter which way around you do it. You can make them B and C or C and B. This really doesn't matter, as long as you got the angle you want to know and the opposite side clear. So let's write that down. Right, so we got cos. I've now relabeled it X, the angle I want to know. B and C is the other two sides, 38.6 and 78.4. This order doesn't matter. So 38.6 square and 78.4 square in any order. But what's important is that I've got this angle in the right place. Side rather, this side, which is opposite, that has to be 94.5, has to be the opposite side. Squared. That's being divided by 2BC. So again, it's those other two sides in any order. Okay. Now again, to make things smoother, we need to do the best thing to do is to put all of this into your calculator at once. So that means I want to do X equals, move the cos across, that's cos to the power of -1, and then put in everything else. On the calculator, it looks like this. Shift, cos, fraction, 38.6 squared plus 78.4 squared minus 94.5 squared, down arrow 2 times 38.6 times 78.4, close the bracket, equal. And I get X equals 102.342 rounded, of course. And since this is an angle, we always round it to one decimal place. That's 102.3. Question 3b. This turned out to be quite a difficult question for many students. Let's see what we're working with here. We're working with the area of triangles. Now remember, there are two formulas for area of triangles. There's the basic one you learned first, which is half base times perpendicular height. And then there's the one you would have learned later on, which is half A, B, and C. Okay, so let's start with the triangle we have the most information with, and that's the first one there. Right. Do we have a perpendicular height of the triangle? For example, that would have been the height of the triangle there, but we don't have it. Okay, or maybe we could have had the height going this way, but we don't have it. I mean, we can try and work it out actually using SOHCAHTOA, but it will be a lot quicker using that second formula. Okay, so the area of triangle 1 is half A, B, and C. This will be the quickest method. A and B being the two sides we have in any order, and C being the angle we have. So we do half A is 21.5 or 27.6, and the second one 27.6 or 21.5, any order, and then the angle 111. So let's put that into our calculator. Half 21.5, 27.6, 111, and bam, that's our answer. Do not round this, because this is not our final answer. Okay, right, let's look at the next question. They say calculate the shortest distance from R to the line PQ. So the shortest distance from the line R to PQ, which we need to recognize here, that will be a perpendicular line. It will form a 90-degree right angle. Okay, so looking at that, it seems that what they want to do here is tell us if we turn this triangle around, this will be the base and this will be the perpendicular height. Okay, so for that one, we're going to use the second formula. Okay, so what will we know? Let's write that down. The area of triangle 2 is half base times perpendicular height. What do we know? We actually know the area because they told us they have the same area. So we know the area of triangle 2 will be 276.99, etc. Half the base is then that value, 34.3, and the height is what we want to calculate. Okay, so to isolate the height, to make it the subject so we can work it out, I'm going to divide all of this on the other side. So that is 276.99, etc., divided by a half of 34.3. So let's put that into a calculator. I still have my previous value there, so my calculation would be very accurate. I just divide a half 34.3. Note my use of brackets there to make sure everything is clear, and I press equal. That gives me H equals 16.151, etc., rounded to three significant figures, 16.2. And we've done it. Question 4, transformations. Make sure you got your ruler and your pencil ready. First one tells us to translate by a vector of -4 and 5. Now remember, in vectors, the top number tells us left or right, and if it's negative, of course, we go left, and the bottom number tells us up and down. If it's positive, we go up. So get a piece of tracing paper, ask for it if they haven't given it to you, and let's do first -4 means 4 squares to the left, 1, 2, 3, 4, and 5 means 5 squares up, 1, 2, 3, 4, 5. Take your time, you don't want to miscount a single square and lose your marks. Mark the corners, get a ruler and draw it. Part 2, reflection and the line x equals 1. So make sure you go on the x-axis to 1 and draw your mirror line going through there vertically. Now reflection means we stay the same distance from the mirror line. So this point here is 2 squares to the mirror line, so 2 squares on the opposite side. Same for the top one. And this one here is again 1, 2, 3 squares, so 1, 2, 3. Look carefully that you don't confuse the y-axis with your mirror line, and then draw it. Last one, enlargement, scale factor 2. Let's start with the center, -5 along the corridor, -2 down the stairs. There is our center of enlargement. Okay, so scale factor 2 means everything has to double in distance. So if we start with this corner here, to get from the center of enlargement to that corner there is 3 squares to the right and 4 squares up. We need to double that distance. Okay, so instead of going 3 from the center, we go 3, 6. And then instead of going 4 squares up, we go up 8 square. So it's 4, 8. And we know it's right because we're on that guideline there. We have now doubled this distance. Okay. Next corner here is the near one nearby. Okay, so this is 4 and 3 becomes 4, 8, and 6. We're on that line. Okay, you can also see this diagonal side here is now 2 diagonal squares, not just one. So we know we're doing this right. You can continue counting the squares, but by now you should have the idea. Right, okay. This side here should be, instead of going 2, we go up 4. And then we can connect the last 2 sides. Make sure you're accurate. Make sure it's clear. Use a ruler and a pencil. Question 4b. Describe fully the single transformation that maps triangle A onto B. So let's have a look there. Okay. Well, it hasn't flipped over, so it's not a reflection. It hasn't changed size, so it's not an enlargement. And it's not in the same orientation, so it's not a translation, so it could only be a rotation. Okay, so let's first of all see if we can find the center of rotation. Good place to start at the origin, but as you can see, we are way off. So let's go a bit to the left. We are getting closer. So I'm going to keep going. Trial and error is probably the quickest way to get this. There, we got it. That is the center of enlargement. Right, so this is my center. Center of rotation rather. Okay, so we have the center. And don't swap this around. It's along the corridor. If it ever happens that this happens, that you write something ugly, draw a line through it and go with it again to make sure you get your marks. Along the corridor and up or down the stairs, we didn't go up or down. Okay, that is 1 mark. Of course, you just say which kind of transformation that is. Rotation. I should have written that down first. And then there's the angle. Okay, let's see if we can make this clear. Which direction are we going? We're going anti-clockwise, and the angle is of course 90 degrees. If you're not sure, we can connect the corner with the center and then connect that same corner again, and there you can see 90-degree angle we have got. So it's a rotation anti-clockwise 90 degrees. 1 mark for rotation, 1 mark for anti-clockwise 90 degrees, 1 mark for the center, and you've got it. Question 5. Let's start off by completing this table. So I'm going to first of all, substitute this -1 into that equation there. So let's do that. What's very important to remember is if you're squaring or cubing or anything, a negative number, put it in brackets. And that's -1 cubed minus 3 -1 squared plus 3, and we get our first value, which is -1. Next one is 1.5. I can go back and then just change each value for 1.5. And there we go. They want this in decimals, minus 0.375. Last one, change that for the 3. And we get 3. Question 5b, let's plot those points. Make sure you work as accurately as possible. First point, minus 1, minus 1. Remember, along the corridor, up the stairs, or down the stairs in this case. Minus a half and 2.125 should be there. 0, 3, 0.5 and 2.375, almost 2.4, 1, 1, 1.5 minus 0.375, around about there. 2 minus 1, 2.5 minus 0.125 on that number, and 3, 3. Looks good. It forms that beautiful wave that we want from a cubic graph. So with a freehand, not a ruler, connect this slowly and as accurately as possible. Beautiful. Go through every single point. When you look at it and you get a good feeling, then you know you've done it right. Right, question 5c is a little bit more of a challenge. All right, let's see. They give us this equation here. I'm going to write it down. X cubed minus 3x squared plus x plus 1 equals 0. And then they say we have to draw a straight line to solve the equation. Let's see what we have. Okay, what we have is we have this graph and we have the equation of this graph, which is this one. So let's write that down. X cubed minus 3x squared plus 3, and that's equal to y. Okay, so we need to look carefully. What has changed? Okay, or lower back. How can we get back to the graph we had? So let's look carefully, right? The x cubed, the s cubed is the same. The minus 3x squared, the minus 3x squared is the same. But we got an x here that was not in the graph that we drawn. So let's subtract that x. But remember, like with any good equation, we need to do the same on the left and the right hand side. So we subtract the x there. And then to get from a 1 to the 3, we need to add 2. Okay, so if we do that to the top equation, we will have the bottom equation, which is great because we've got the graph for the bottom equation. Oh yeah, we do plus a 2 there, we do plus a 2 there. Okay, so that makes these two equations the same. So what we have on the left-hand side is another equation. You see that? On the right now, we got minus x plus 2, and that will be equal to y. So that is the straight line they mentioned we have to draw, minus x plus 2. Okay. Now, drawing this line is not going to be too hard. Okay, first of all, you want to know where it crosses the x-axis. Let's do x or y first. Okay, let's do the y-axis first, right? We want to know where it crosses the y-axis. We make x 0. So that will give us y equals minus 0 plus 2, which of course is just 2. So we know this line will cross the y-axis at 2. Brilliant. Okay, let's make the y 0. So that gives us 0 equals minus x plus 2. Move the x to the other side. That gives us x is 2. That's one of many ways to find the line. But now that we have where it crosses the y and the x-axis, we can now draw a straight line. Be sure you are as accurate as possible. Okay. We'll notice that it crosses 3 times, which is great because we need 3 answers. X equals, X equals, X equals, and it's X equals, so it means we're going to read the answer of the x-axis. So, where shall we start? On the left. Okay, once again, working accurate. Let's go straight down. be conscious of the scale. Each square here counts for 0.05, isn't it? So wait, this will be minus 0.1, minus 0.2, minus 0.3, minus 0.4. I get minus 0.45. Second one where they cross, oh my goodness, there we go. Second one where they cross is right there. This one is obvious. That is going to be a 1. It looks so beautiful. And then the last one. Okay, again, let's look carefully. That's 2.1, 2.2, 2.3. I'd say 2.4. And we got 3 answers. Okay, if you've done this at home, you will know what the mark scheme says. The mark scheme for the first one says anything from minus 0.45 to minus 0.35. So minus 0.4 basically, or minus 0. Right? That one needs to be a 1. There's no leniency there. And for the other one, anything between 2.35 to 2.45. Okay, so my 2.4 is correct as well. My minus 0.45. So they gave you a 1 square leniency there. Well done. You're going to get this right. Question 6a, first one, solve. There is 2 approaches here. You can multiply out the brackets first, or you can divide the 4 first. Let me do both. Right, so first approach here would be to divide both sides by 4. So we'll be left with 2x minus 3, 24 divided by 4 is 6. Then we add 3 to both sides. So that gives us 9, and then you divide it by 2. So you get the answer 9 over 2, or 4.5, or 4.5. Write any one of those. Don't write them all, any one of those. The other approach would have been to multiply the other brackets first. So 4 times 2x is 8x. 4 times minus 3 is minus 12. Then add the 12, so you get 8x equals 36, and then divide 36 by 8, which will get you, of course, the same answer. Yeah, no problem. Okay, 6a part 2. Don't let the sign throw you off. We do the same thing here. We subtract the 14. Subtract 14 from both sides, or do 6 minus 14. What would that be? Minus 8, of course. And then divide the 6. They don't say anything about simplest form. Okay, but simplify it anyway, just to be safe. Put it into your calculator and write what your calculator says. Minus 4 over 3. Okay, or if you want to do a decimal or a mixed number. Okay, oh, be careful here. Be careful, because there was an x equals and there's no here, and that sign is important. It's not the same as this equal sign. So you need to write the whole thing. X is less than minus 4 over 3, or 1 and 1/4. Okay. Question B, rearrange the formula. We need to make y the subject. Okay, so we always start the furthest away from y, opposite of bit mass. So if y was a number, what happens to y? Well, first it gets cubed, then it gets multiplied by 3, then it gets subtracted from all of that. So we're going to start with that, the 2x cubed. Okay, and move that to the other side. So that will be v, and it's positive, so it becomes negative. All right. Next, what will happen is y, well, after y has been cubed, it gets multiplied by negative 3. So now we need to divide that on the other side. So the next step will be 2x cubed divided by negative 3. And then lastly, there's the cube. Opposite of cube, cube root. So we cube root all of that. Right. Now, that should be correct, but I see the examiners like it when you divide that negative into the top terms. So that means we just change the signs. They don't need to like to leave a negative at the bottom. So the minus 2x cubed becomes a positive 2x cubed. The v becomes a negative v, and we got a 3 at the bottom. And you've done it. Question 6c can be a little bit confusing, especially that last part of multiple of 4 and all integers values of n. So if you're confused, start with what you know, and you know how to multiply out a double bracket. So 2n minus 5 is the same as 2n minus 5 times 2n minus 5. Okay, now let's expand that bracket. 2n times 2n is 4n squared. 2n times minus 5 is minus 10n. Minus 5 times 2n is minus 10n. And minus 5 times minus 5 is a positive 25 minus 13. Simplify it, collecting like terms. Minus 10n will give you minus 20n. 25 minus 13 is 12. That's really good. Now we need to address the next problem. Multiple of 4 for all integer values of n. Now can you see that each one of my terms is a multiple of 4? So you can write that down, for example. Okay, you can write each term is a multiple of 4, or you can write 4, negative 20, or 20, and 12 are all multiples of 4. That's an explanation. Or you can factorize out that 4. You can say 4n squared minus 5n plus 3, and say, look there, they're all being multiplied by 4. Just factorizing it out seems to be good enough for the examiner. Okay. So when a question is a bit confusing, you read it, you're not quite sure what to do, start with what you can do, and that is expanding those brackets. And as you go along, things might become more clear. That's how to approach these questions. Question 6D. This is a challenging question, all right? It's clearly completing the square, and I kind of swap things around as well to make it a bit more confusing. I'll put a link to completing the square in the comment section if you've forgotten how to do that. Okay, so let's get started here. First thing we need to do here is we need to factorize out from here a common factor before we can complete the square. So logical thing would be to factorize out just the 2. So that gives us 5 plus 2 gives us 6x minus x squared. Okay, now that means we can now complete the square. So completing the square looks like this, if you remember correctly. We half that term, which half of 6 is 3, and we take the square root of that, and then we square it. Problem I see now is that in here, x is positive, and we got x negative here. So it might have been smarter to factorize out not the 2, but a negative 2. Okay, so when I now factorize a negative 2, that would change the signs. So that means that minus 2 times 6x is a positive 12x, and minus 2 times x squared is minus 2x squared. Okay, so I've just changed the signs there. Right, now let's see if that is correct. Let's test it. Okay, so because when I multiply this out, what I've got here now, it should still be equal to that. Okay, let's see if that is true. Let's see if it is. Okay, so here we go. we got minus 2 bracket minus 3 plus x squared. Leave the minus 2 in front. Minus 3 plus x squared means minus 3 plus x multiplied by itself. So that will give us minus 3 times minus 3 is 9. Minus 3 times x is minus 3x. X times minus 3 is minus 3x. And x times x is x squared. Right, now we multiply and that minus 2. That gives us minus 18. We could have simplified this first. Minus 3x is minus 6x times minus 2 will give us plus 12x. And minus 2 times x squared is minus 2x squared. This all looks pretty good. I mean, we got the 12x. We got the minus 2x squared. The problem is here that negative 18, which is nowhere to be seen anywhere else. So we need to get rid of that. So once we completed the square, like we did in this step, we need to add 18 to cancel that negative 18 that appears from nowhere later on. Okay, so what does that mean? That means I got 5 plus 18 is 23 minus 2. They got the x first, so I got the x there. Luckily it's positive. So we're basically just swapping this around. The minus 3 goes there, squared, and we've done it. Okay, so P is what is over here, negative 3. That's P. And Q is what we got there, 23. You can do this. Question 6D, part 2. They want us now to write the coordinates of the maximum point on the curve. Okay, the curve, right. For that, we use our previous answer, right? This is one of the benefits of completing a square. You can find the maximum point. But let's see what it looks like on a graph. So there it is. There we go. I've graphed it. The equation they've given us there, 5 plus 12x minus 2x squared. Okay, if I take that away and put the one that is completed square form, you can see exactly the same. And the maximum point there is the turning point, and there it is, 323. Now, if you look at completing the square form, we got a 23 there and a minus 3. Okay, so what's inside the brackets will always be our x coordinate of the turning point if we change the sign. The minus 3 needs to become a 3. And what's over there, 23? That is our y value. Let me show you another one. I've got a very similar equation here. The difference now is I've got a plus 3 there. So the x value for the turning point is going to be minus 3. You have to change the sign, but the 23 stays 23. The y value stays the same. Let's look at one more. Okay, that's again, you see that? I've got a minus 3 there. Turning point is 3. So change the sign. Turn to 23 stays 23. So getting back to the paper. Okay, what we have to do is we need to take that little 3 there, change the sign so it becomes a positive 3. Just write it nicely, please. And the y value stays the same. And you've got it. Question 6e, another little challenge. Let's write this down. Right, the energy, let's call it E, of a moving object is directly proportional to the square of its speed. So in mathematical language, we will write the energy is proportional to the square of its speed. It will look like that. Okay, that's the proportion sign. Then it says the speed of the object is increased by 30%. Always, it's the same. When you increase something by 30%, you take 100%, you add 30%, you end up with 1.3, 130%, of course. Okay, which as a multiplier or a decimal is 1.3. So meaning that we've now taken the speed and we've increased it by 1.3. So let's do that. So the speed is not now what it was. Imagine it was 100%, which means it was 1. It is now 1.3. So let's Type that into a calculator. 1.3 squared gives us 1.69. Okay, now that is a decimal multiplier. What does 1.69 mean? 1.69 is 169%. When do I get 169%? When I take 100% of something and I increase it by 69%, then I get 169%. Okay, so what's the percentage increased? 69%. Got it. Question 7. A. The diagram shows a container with a storing grain. It's made of a hemisphere. Don't forget that hemi. A cylinder and a cone, and then it gives us the information. Right. First, it tells us to calculate the volume of the hemisphere, and they give us the formula. So let's write that down. The formula is V equals 4/3 pi r. What's the radius of the hemisphere? There it is, 2. So that is 2 cubed. So let's put that into our calculator. Fraction 4/3 times pi 2 cubed. Okay. All right, so give us that answer. Let's go with this one. 32/3 pi. What do we need to do next? Well, we need to look carefully, right? What was this? This was the volume of a sphere, and that's a hemisphere. So we need to divide that by 2. Okay, maybe it would be better to show that from the start. Divide by 2, and there we go. 16/3 pi. Now, give your answer as a multiple of pi. Well, that is exactly what our calculator has done here. 16/3 pi. Okay. If your calculator doesn't give your answer automatically like mine, you can just do the whole calculation without pi. So meaning you will do 4/3 times 2 cubed without the pi. There you go. And then divide by 2, of course. 16/3. That's it. And then you add the pi. And you've got it. Question 7a, part 2. They're talking about the total volume of the container. So let's write down what we have regarding that. First of all, there is the area of the hemisphere, the volume of the hemisphere, which we have just calculated here. So let's write that down. 16/3 pi. Then there is the volume of the cylinder. And if you remember correctly, a cylinder, the volume is the area of the cross section, which is a circle, pi r squared times the height. So that would be pi r squared h. Then we got the volume of the cone. They're given to us there. It's 1/3 pi r squared h. And if we add these 3 things together, we will get the answer they've given us, 88 pi/3. Right, let's substitute in there which we can. For example, r, the radius, it is 2 throughout, so we can substitute the 2 in there. So that will be 16/3 pi plus pi 2 squared. And then there's h, of course. H, first the height of the cylinder, which is 5.2, which is not the same as the h of the height of the cone that we have to calculate, but the radius we have, that is 2 squared. Okay, now looking at this, I immediately notice one thing, and that is that every term has a pi. There's a pi there, there's a pi there, there's a pi there. Hey, highlight. And there's a pi there. Okay, every term has got its pi, meaning if we divide everything by pi, which we can do because pi is just a number, we will cancel all of the pi. So that will leave us with 16 over 3 plus, we can simplify this a bit. We can do 2 squared times 5.2. That's 104 over 5. And we can simplify this. That's a third, which of course is 4 over 3. H equals 88 over 3. Now that looks a lot more doable. It's just numbers. Okay, so first of all, to isolate the H, I can move all the terms that doesn't have an H to the other side. So that will give us 88 over 3 minus the 16 over 3 minus the 104 over 5. So don't fluff around with this. Just hammer it into your calculator. Save time. And we got an answer. So where are we at now? With 4 over 3h equals 16 over 5. Next would be, well, there's different ways to mention this. We can just divide that. Yeah, let's do that. It's 4 over 3 times h. So we can do 16 over 5 divided by 4 over 3. So we divide this by 4 over 3. And we get an answer. H equals 12 over 5, which gives us 2.4. And we've done it. Question 7a, part 3. There's a lot of information again, but if we use it correctly, it can help us. For example, the rate of 35,000 kilogram per hour, we can turn that into a formula. Okay, kilogram per hour means kilograms divided by hours. Okay, so if we're going to make a little triangle, kilograms per hour, and what does that give us? That gives us the rate. So if we need to work out the time, which is this one here, we need to do kilograms divided by rate. Okay, so what do we have? What is the kilograms? Kilograms is 620 kilograms per 1 cubic meter. Do we have cubic meters somewhere else? Yes, that was given to us in the previous question. Cubic meters, the volume of the whole container. So if every 1 cubic meter weighs 620, we need to multiply this together. So that will be 88 pi over 3 times 620. Let's do that. And we get this big answer. Okay, either way you want to write it is fine, as long as you don't round it yet, because this is not the final answer. Okay, so what do we have now? We now have kilograms of the whole weight of the whole thing. We have this. If we now divide it by the rate, we'll get the time. So we take this answer and we divide it by the rate, which was 35,000. Still have that in my calculator, so I can just divide it, keeping everything accurate. That gives us 1.632, etc. hours. Okay. Now, this is not 1 hour and 6 minutes or 1 hour and 63 minutes. Okay. It is 1 hour, but of course, you can't have more than 60 minutes. Okay, we need to remember that decimals is base 10 or 100, okay, whereas time is base 60. So if I'm going to subtract that 1 and just now work with a decimal value there, all I need to do is multiply that by 60, since time is different, okay, to convert it to minutes. And there we go. That will be 37.9 etc. minutes. And 3 significant figures is the way to go. So I think writing 37.9 is a safe bet. If you want to be accurate, I see on the mark scheme, if you write 1 hour, 38 minutes, that will also be correct. Okay, or 37.8. And we've done it. Question 7b, another challenging question, but here we go. Right, they give us the area of the shaded segment. So let's think, how would we work that out? First of all, we'll have to work out the area of the whole sector there. Okay, you remember that correctly? That is part of the area of a circle, which will be pi r squared. And then we need to multiply it with the fraction of the circle it is. So it'll be the angle divided by 360, and we'll get the area of that sector. Then from that, of course, we will have to subtract this triangle, and then we'll be left with the area of the shaded part. How do we work out the area of a triangle? Half base times perpendicular height. Or if you don't have perpendicular height, we do the other formula, which is half A, B, C. Once we've done that, we'll get the answer of 65 centimeters squared, as they told us. So let's put in there all the information we can. So first of all, we got pi r squared. We don't know what's pi, but we know that this angle here is 140 degrees. They've given that to us. Half A and B is the two sides of the triangle that encloses the angle. So we know that A probably is r, and since this is the radius of a circle, those two lengths is the same because they're both the radius. The radius is always the same, so that's also r. So B is also r. So this will be r times r, or r squared, and then sin C is the angle. Now we can start simplifying this. Okay. First of all, they're 140 over 360. Put that in a simpler form, and we multiply that with this, so that will simply be 7 over 18 times pi r squared. Right. As well, we can work out sin 140, but I mean, it's going to give us a big decimal number, so it's more accurate to leave it the way it is. Okay, now what I notice is, right, we need to find what is r. And we got r squared in two places. We got r squared there and r squared there. To make it simpler, we can factorize that out, put it in front of the bracket, and we're left with only one r squared. So inside the bracket will be everything that's left in each term. 7 pi over 18 minus a half sin 140 equals 65. We can calculate everything in that bracket now and get a decimal answer. But it's better if we do it all at once, just to avoid working with too many decimals. So since this is r squared times everything in the bracket, we can now divide everything on the other side. So that will give us 65 divided by 7 pi. Let's just write that correctly. So it looks like to the power of pi. 7 pi over 18 minus a half sin 140. Okay. Let's do that. Let's put that in the calculator. So 65 over another fraction, 7 pi over 18, side arrow. Take care to make sure everything is correct using the arrows on your calculator and brackets where needed. Okay, and there we go. So that will give us r squared equals 72.195, etc. Don't round yet. We need to get rid of that square. So that means r is the square root of all of that. Okay, so we do square root, and now with not use the most accurate answer will be just to insert the previous answer, and there we go. We got the answer 8.496, etc. Rounded to 3 significant figures is 8.50. Once again, we've done it. Question 8a. Let's keep our head together and we'll figure this out. Okay, Katya runs along a 12-kilometer path at an average speed of x kilometers per hour. Again, there's a little formula there, the one you know. Kilometers per hour is kilometers per hour, which gives us speed. And if we change that kilometers to distance and hours to time, it would look very familiar. Distance, time. Okay, so it says write down an expression in terms of x for the hours taken. So that's the time. We want to know this. So we need to do distance divided by time. We got the distance there, 12 kilometers. We need to divide it by s, the speed, which they've given us is x. And that's it, 12 divided by x. That is the time it takes for Katya to run along this path. Okay, then Yuki comes along and takes 1.5 hours longer to walk along the same path as Kaito. She walks at an average speed of x minus 4. And then we have to do lots of stuff, algebraically, jujutsu, to get that. Okay, so we're working with the time. We've got the time it takes Kaito. So let's work out the time it takes Yuki. So again, we need to take the distance, which is the same path. So for Yuki, it's going to be 12 and divided by the speed, that is x minus 4. So this is the time it takes Yuki. Okay, we need to write an equation. So we need to put an equal in there. So Yuki's time will be the same as Kaito's time, but 1.5 hours longer. So we can add 1.5 to that. Right, now we need to somehow go from here to there. Let's have a go. Okay, this looks a lot like algebraic fractions to me. So let's first move this to the other side so we can add them together. So we've got 12 over x minus 4 minus 12 over x equals 1.5. Okay, if you remember how to add together algebraic fractions, like normal fractions, for example, if we add a half plus 2/3, we multiply the denominators to get the common denominator, and then we multiply across. Well, this is one method to get similar fractions. So we're going to do the same here. We're going to multiply the denominators together. So that will give us x over x minus 4. And multiply across 12 times x is 12x. And multiply this, well, it's minus 12 times x minus 4. Okay, cannot cancel those x minus 4s because there's a minus there. Okay, so let's multiply out that bracket. So that gives us 12x minus 12x plus minus 12 times minus 4 is plus 48 over. Okay, we can get rid of that denominator now. Okay, let's do that. If we multiply this x minus 4 to the other side, so that will give us 1.5 times x minus 4. Good. No more fractions. Okay, let's simplify this. 12x minus 12x is 0, so we're left with 48. let's write that down. And on the other side, 1.5x times x is 1.5x squared. And 1.5x times minus 4 will give us minus 6x. Check it with your calculator. 1.5 times 4 is minus 6. Right, we need to have everything equal to 0. So I'm going to put the 0 just in the front. So leave 1.5x squared and 6x where it is. And move the 48 to the other side. Okay, we can swap that around if we want to. So 1.5x squared minus 6x minus 48 equals 0. Now, do we have what they want us to have? They want us to have this up here. Okay, so let's look at it. We want in front of the x squared the 1. We got 1.5x. If we divide everything by 1.5, which we can do, this 1.5x squared would just be x squared. What is 6 divided by 1.5? 6 divided by 1.5. Yeah, that is 4. And what is 48 divided by 1.5? That is 32. And we've got what they wanted. Well done. Part 3 says now to solve by factorization. Okay, very important. They say factorization. Okay, so you can't use the quadratic formula and expect to get full marks. If you do use the quadratic formula, use it in secret. But we can do this. Remember now, when we make two brackets to factorize, we'll put an x there and an x there. And the two last terms, when we multiply them together, we need to get minus 32. So think of two factors of 32. What springs to mind is, let's say, 8 and 4. 8 times 4 is 32. One of them has to be negative, of course. Okay. And let's put the negative there, since when we add them together, we need to get a negative number. So it's better to make the bigger number negative. And when we do that, then minus 8 plus 4, we get minus 4, which is the middle term. So that looks good. X minus 8, x plus 4. Okay. No harm in quickly double checking. So take a pencil and just quickly check. Is that right? X times x is x squared. X times 4 is 4x. Minus 8 times x is minus 8x. Minus 8 times 4 is minus 32. Yep, we got the minus 32. We got the x squared. And 4x minus 8x is minus 4. So yeah, it is correct. Double check. The more you practice, the quicker you'll get at this. Right, now that's the factorization part done. Now we need to do the solve part. Okay, we can put each of these brackets equal to 0. So that means moving the 8 across, x equals 8. And moving the 4 across, x equals minus 4. Part 4, it says find the number of hours it takes Yuki to walk along the 12-kilometer path. So what was the time it took Yuki in algebraic terms? And we kind of had it here, up here. Let's just highlight that. It was 12 over x minus 4. Okay, let's have a look. We need to substitute that now. 12 over x minus 4. If we put the negative number in there, we're going to get a negative answer. Now, she wasn't going back in time, so I guess we're going to have to put in the positive x value, which gives us 8 minus 4 is 4. That gives us 3 hours. Now, we've done it. Question 8b. The bus travels 440 kilometers. Correct to the nearest 10 kilometers. So when you see that, correct to the nearest, you know you're dealing with bounds. First thing you need to do, you take that 10 kilometers and you divide it by 2, you get 5. Okay, that is the number we are going to add and subtract the 440 to get the upper and the lower bound. So first, the lower bound will be 440 minus 5, which is 435 kilometers. Okay, so that is the shortest possible distance that the bus travels. The upper bound will be at the 5 is 445 kilometers. Bus travels somewhere between those two distances. The time taken to complete the journey is 6 hours. Again, that is not correct. It's nearest half an hour. Okay, half an hour. Yeah, what is that? That is 0.5 of an hour. Again, we divide that by 2, we get 0.25. So, taking that 6 hours to get the lower bound, we need to subtract 0.25. That will give us 5.75 of an hour. Shortest possible time. 5 hours, 3/4. 5 hours, 45 minutes. Yes. Upper bound, we add that quarter hour, so it's 6.25 hours. 6.25 hours. 6 hours, 15 minutes. So somewhere between those two bounds is the actual time. They want us to calculate the lower bound of the speed. So again, go back to our little triangle. Speed, distance, time. Meaning we're going to have to divide distance by the time. So 440 divided by 6, but using the bound. We need to get the smallest possible answer. Okay, now always when we are adding, no, when we are subtracting and dividing with bounds, you know it's complicated. We need to be careful. It's not straightforward. We need the smallest possible answer. Okay, so what we're going to do is we're going to take the smallest possible distance that they travel, which is 435 kilometers. But when we divide it, we want to get the smallest possible answer. So if we divide it by the biggest possible time, that will give us the smallest possible answer. I hope that makes sense. Okay, so let's see. 435 divided by 6.25. That gives us 69.6 kilometers per hour. If you're not sure if this is the correct way to do this, just try out all the other options. Look, 435 divided by 5.75, we get 75. That is way bigger than 69. 445 divided by 5.75, 77. It's even bigger. Or 445 divided by 6.25, 71.2. You can try out all four options or try to remember this. So that is our final answer, 69.6 kilometers per hour. Question 9a. This is all about vectors. They can tell us about a point and then a column vector. Let's see what that looks like. So having a point, there it is. This will be point F, 5 minus 2. Then we have a column vector starting at F as well, going to G. And remember column vectors correctly. The top number tells us left or right, and if it's negative, we go to the left. Bottom number tells us up or down. Positive, of course, going up. So we go 2 spaces to the left and 3 spaces up. So let's do that. Let's just get a pretty color. So column vector is 2 to the left and 3 up. And this is where we are now. Okay, so our vector would look like this. And of course, with an arrow. And over here we got G. What is the point there? Okay, this will be the point, of course, 3 and 1, as you can see on the x and y axis. So we practically add, wait, there we go, 3 and 1. Okay, it helps to draw a sketch even if you don't have a grid like I do. Draw yourself a little sketch. Right, 5FG. It now means we take our vector and we make it 5 times longer. Okay, so this is going to be huge. This minus 2 to the side now has to go 5 times more, which will be minus 10. And this 3 going up will be 5 times more, so that will be going up 15. Working it out, though, is a lot more straightforward. All we need to do is we need to multiply the minus 2 by 5, that's minus 10, and multiply the 3 by 5, that is 15. Right, question 9a part 3. These little lines, they indicate positive answer. Also the magnitude of vector fg, or how long that line is. So that is fg. Remember, for fg we moved 2 spaces to the left, and then we moved 3 spaces up. That means this line here is 2, and that line there is 3. And yes, what we have now is a right angle triangle, which means we're using Pythagoras. If you do this without the sketch, of course, you can write it like this using the formula. Well, not really a formula, but it's the square root of the 2 parts of the vector, which was 3 squared, and the other one was minus 2. So if you put the minus there in brackets and square it, or you just square 2, it doesn't matter, because it will be positive when you square it anyway. Okay, so that's all we need to do using Pythagoras, and that will give us 3.605, etc., rounded to 3 significant figures, 3.61. Question 9b, vectors. Let's tackle this beast. OABC is a parallelogram. That is important. Every piece of information is important. Opposite sides of a parallelogram are parallel, and with vectors, that means if they are parallel and they are the same length, they are the same. That means if OA is little a, CB is little a in the same direction. If OC is C, then AB is C as well in the same direction. Okay. Then it tells us P is a point on AC. Yeah, we can see that. And the midpoint Q is the midpoint of AB. That means this is half of that line, that is half, and we know now that they are both C. Okay, so that's a half C and that's a half C. Right. Find in terms of A and or C AQ. So I think we already figured this one out. AQ being that line there, we just figured it out. That is half AC, which is half C. Sorry. Okay, next one, OQ. So OQ will be the line going from O to Q. Let's do this properly. That's the vector OQ. Let's follow a path that we know. That will be from O to A and from A to Q. Okay, write that down. So we take the path from O to A plus A to Q. O to A being A, and A to Q, we just got that's a half C. So that's A plus a half C. Right. For the next part, it tells us OP is 2/3 A plus 1/3 C. Show that OP and Q lie on a straight line. Now remember, with vectors, if they are the same direction, they have the same value. For example, if I've got a vector called B, we don't have one, is that B? Then if I have the vector half B or 3B, any of those, they won't be equal, but they will be in the same direction. Okay, they will be parallel. So we can kind of do the same thing here. Okay, we got OP and Q. For that, we got OP is 2/3 A plus 1/3 C. We got OQ. They are all part of the line OPQ is A plus a half C. Now we can get that kind of the same. We say they are multiples of each other, then they will be in a straight line. So what I'm going to try and do, I'm going to try to get that A the same. Let's make the A for both 1A. So to do that, I need to factorize out 2/3 of the first vector, meaning I take out 2/3. So 2/3 times A is 2/3 A. 2/3 times what? C will give me a third C. Let's just do the opposite. Let's do a third divided by 2/3. Okay. What does that give us? A half. Okay, so that means that's a half. Double check, yeah? 2/3 times a half is 1/3. Okay, so now, as you can see, we have something here. We got A plus a half C and A plus a half C. Don't let that one confuse you. Okay, that clearly shows us that OP is 2/3 of OQ. See that? Because they're both a multiple of the same thing. So let's just give an explanation, short explanation. Okay, like it says on the, well, that's enough actually to give you full marks. If you didn't show that maths, then you give an explanation, right? They have the same base vector. They are both multiples. Both is multiples. And they share a common point. This is a tricky question. With enough practice, you'll get these things right. Okay, next one. They say write down the ratio of OP to OQ. Now, I already had that before. Okay, I had OP is 2/3 when OQ is 1. Okay, I'm referring to here. These 2/3, whereas we put this in brackets, that will be 1. That's why it's 2/3. What they want us to do though, they want the first value in the ratio to be 1, which means I just need to divide this by 2/3 on both sides. So on my calculator, I'm going to type 1 divided by 2/3. What is that? Okay, which will give us 1.5. So it's 1 to 1.5. And you've done it. Question 10a. We're talking about the turning points of a graph. Let me show you what's going on here. Let's go. There we go. You see, there is the graph of x cubed minus 12x plus 6. The turning points, as you can see, there's one up there at minus 222 and one down here at 2 minus 10. Now, if we were to draw a tangent at those points, it will look like that. There's the one in green. There's the other one in purple. What do we know about the tangent? The gradient is 0. So we just need to find where on the graph is the gradient. Which point is the gradient? 0. That is the turning point. Okay, and of course, finding the gradient at any point on a curve, we use differentiation. So we need to differentiate that. That will be dy over dx. Okay, differentiation. We need to imagine there's a 1 in front of that x. So 3 times 1 is 3. X, subtract 1 from 3, that will be 2 squared. Next, imagine there's a little 1 up there. 1 times minus 12 is minus 12. X to the power of 1 minus the 1 there is x to the power of 0. Anything to the power of 0 is 1. 12 times 1 is 12. So that x can just fall away. Okay, so there we go. Get rid of those brackets. Okay, next thing we know is that the gradient at the turning point is 0, so we can set this equal to 0. Okay, then we need to solve. Let's move that 12 across, so that gives us 3x squared equals positive 12. Divide the 3 So that gives us 4 and then square root of 4. Okay, as you know, we have two possible answers, 2 points, and we know that if we square negative numbers, it becomes positive. So, basic example, of course, 2 squared equals 4. That is why the square root of 4 is 2. But minus 2 squared also equals 4. That's why the square root of 4 can be minus 2. And we have two answers, positive and a negative one. That means x can be 2 or x can be minus 2. So we now have the x coordinate values. To find the y-intercept, where do we have a y? Up there, there's a y, so we put the x into this equation. So the first one, when x is 2, we do 2 cubed minus 12 plus 6, and that will give us minus 10. And we do it again with a negative, so it's minus 2 cubed. Make sure to use brackets here when you cube it, although actually when you cube a negative number, it's not that important. Do it right, you get 22, and we have our two turning points. Right, next question, question 10b. Determine whether each turning point is a maximum or a minimum point. Show how you decide. Now, there is many ways to do this. In the math team, they talk about a second derivative, etc. I think the clearest way is just to draw a quick sketch, and this is perfectly fine to do. You draw a quick sketch, and on there you show what the graph looks like. So first, let's indicate the 2 points. 2 minus 10 will be there. And minus 2, 22 will be up there. Okay. And as knowing what a cubic graph looks like, you can draw a line like this. All right, and that clearly shows where the maximum and the minimum point is. We can say the maximum point, also known as the maximum point, because the y value is the highest, and this here is the minimum point. The y value is also the lowest. That should be clear enough to give you your full marks. Question 11. Here we go. We got two similar triangles, so it means we're talking about a ratio here. The one is scale factor of the other one. They want us to find yz first. So let's write that down. Yz over the corresponding side here is RQ, so that's 15.3 is equal to, now we put the smaller triangle first on this side, so we need to put that value first, 13.6 over 20.4. Okay, so to calculate yz, we just need to rearrange that. First thing is we multiply the 15.3 on the other side. Okay, so we hammer that into a calculator. 15.3 times 13.6 divided by 20.4. Bam, got 100. Yeah, 102 can possibly be right because I put that decimal point in the wrong place. So let's just correct that. Now that makes more sense. 10.2. Right, part 2. Let's have a look at that one. Okay, they now tell us that where are we at? XYZ is got a area of 63.6 centimeters square, and we need to find the area. Let's make it X of the bigger triangle. So again, let's write it down as it is. And this time I'm going to write down the units because this is important. So the area of the bigger triangle, we write it over the area of the smaller triangle. And this time, because I wrote the bigger one first, I need to keep doing that. So it's 20.4 centimeters over 13.6. Okay, so on the left there, we got an area scale factor. On the right, a linear scale factor. That's not the same. We're not in the same dimension at the moment. Okay, centimeter squared, centimeters, not the same. That's why we need this scale factor here. We need to square it. And that's it, yeah, to make sure it's the same. So what's it going to look like? So if we want to work out what is X, let's just rearrange this, multiply this on the other side. So that's 63.6 times the linear scale factor, which we got by dividing this, squared. So let's do that. 63.6 times 20.4 over 13.6 squared. And we get 143.1. Don't round this to 3 significant figures. It's exact. And we have the answer. Right, getting to question B. We got two containers mathematically similar. Let's draw a sketch there to help us out here. So imagine, let's make them a cuboid or a cube. Doesn't matter. There's a big one and there's a small one. Right, the larger container has a capacity of 64.8 liters and a surface area of 0.792 meters squared. Smaller container, capacity of 37.5 liters. And let's make it X. The surface area is what we want to know. So again, we're talking about similar shapes here. We use ratios. So we want to know what is the surface area of the smaller shape. So we write it as a ratio over the bigger shape. Surface area, we're going to set that equal to, put the smaller one first. So again, smaller one over the smaller one. Okay. What is liters? Liters is capacity, right? Another way to measure a liter is to measure it in centimeters cubed, for example. So it means that my ratio on the left is area, and my ratio on the right is volume or capacity. And like we did before in the previous question, we need to get that equal, and we did that by squaring the linear scale factor here. So what we're going to have to do with this one here, to make sure we get both as an area scale factor, we're going to have to square it on this side, but also because this is centimeters cubed volume, we're going to have to cube it on this side to make the scale factors equal. Okay, it's one way of explaining this. All right, so we need to rearrange that and then sort it out. So first of all, to find that X there, I need to get rid of the cube. So what we'll do is we will cube root everything on that side. And it looks like that. And of course, then to get the X alone, we need to move this 0.792, multiply it on the other side, and it will look like this. Okay, so all we need to do now is hammer that into our calculator. So we got 0.792 times shift the cube root of 37.5 over 64.8 bracket squared. And bam, we got our answer, x equal 0.55 meters squared. And you've done it. Thank you for watching. I hope you found this helpful. Keep working hard, keep studying hard, leave some comments. Remember, you can do it.